So polynomial functions and the order of the x-intercepts. So they've given us a polynomial function, and luckily they've given us, this is called a factored form. And what's great about factored form is it's very easy to find out what the x-intercepts are of a factored form. Okay, so what we'll do is we'll figure out how to look at it algebraically, and then we'll switch over here and we'll take a look at the graph. And obviously, because we had a graphing calculator, we can kind of check to make sure what we did is correct. Okay, so x-intercepts are essentially when the y value is 0. So when a y value is 0, that means our function is kind of set equal to 0. So think of it like 0 is equal to, so we replace the f at x with 0. 1 over 7, and then x minus 2, x plus 2 squared, and then x minus 1 cubed. So what we want to do is isolate for kind of each of these sets of brackets. We have this 1 over 7 here. And because this is all multiplication, okay, in order to move 1 over 7 to the other side, we would divide, right? So we would go 0 divided by 1 over 7. It doesn't really matter, even though it's a fraction, it looks complex. 0 divided by anything is just 0. So the idea is that, yeah, it's cancel out. It's gone. So really what we're working with is 0 is equal to x minus 2, x plus 2 squared, and x minus 1 cubed. So each of these kind of represents, think of it like a term number. Okay? This bracket represents, maybe if this was 3, it would be -1. So they all each represent some value. In order to have multiplication, so values multiplied by each other and get 0, one of them have to be 0. It's the only way to get a 0 is to multiply by 0. So what we're going to do is we're going to test, we're going to go on the assumption that any of the brackets could be 0. So we split each one and set them equal to 0. So we have x minus 2 equals 0, x plus 2 squared equals 0, and x minus 1 cubed equals 0. Okay. In the first example, it's pretty simple. We just move 2 to the other side. So one of the x-intercepts is going to be positive 2. Okay. Here we take the square root. Since we have the power of 2, we take square root of the other side. And what's really nice about that is the square root of 0 is 0. And then the same goes for this. The cubed root of 0 is 0. So really these powers aren't really that important either. We just wrote them in to show you that we are using all the values that are in there. Okay, so as we go through it, this ends up being, that's going to be 0, so you get x plus 2 equals 0, which means x is equal to -2 is another one. And then finally, same idea, cubed root of 0 is 0, x minus 1 is 0, x equals 1. So those are the values of the x-intercepts. But the powers are important in terms of what the graph does there. Okay, so this one's to the power of 1. So that's when they talk about the order of something. So this is the order of 1, okay, because it's to the power of 1. And what that means, it's kind of like a linear function. Think of, if you recall, linear functions where f at x equals x to the power of 1. That's just a straight line. So it's a straight line going through the x-intercepts. That's exactly what's happening there. This one here, because it was to the power of 2, is of the order of 2, okay? And f at x, when it's x squared, is a quadratic. Yeah, so it kind of does what a parabola does at that value. So it's just touching the x-intercept, okay? And the power of 3, have you guys done cubic functions at all? Does that funny little like s? Yeah, it does that funny little s thing. So there's order of 3, which is, we'll emphasize it. It still goes through the x-intercept. It just kind of does like an s, you could say, through the origin. Yeah, exactly. And this one is just, it's not just through the origin here. This one is exactly through the x-intercept. You're right, for x cubed, that is technically through the origin. So let's take a look at what we got here. Let's see if I can, yeah, here we go. So -2 was one of the values, and -2, that was our middle one, was to the power of 2. No, I don't need a maximum value. +1 was one of our values, and 2 was one of our values. So let's take a look at them. I'm going to turn on this thing here. Okay, so 2 was from this bracket, and that one went straight through. It'd be nice if I could zoom in. If I could, yeah, I can. Let me just let's zoom in a little. Here we go. It's kind of going right through it. Okay, so because it's going right through it, that's our magnitude of 1, kind of our linear function. Okay, now this here was our magnitude of 3. A little harder to see, but it is kind of turning downwards and across. It's hard to see there. If we zoomed in a lot more, you could kind of see the emphasis of it. And then finally, let's Move over here. Our negative 2 represented by our power of 2 or our order of 2 is like a quadratic, and this part of that function is very, very much like a quadratic. Okay?
Our teacher explained if it's squared, it does like a bounce, so it doesn't go through the x-intercept.
Yeah, that's a good way to think of it.
If it's odd, it does the squiggle.
Yeah, that's exactly. Anything that's odd is gonna cut through. Anything that's a even number is gonna turn back up. It's gonna stay on the same side of the x-axis as it approaches. Okay.